Pre-polished splice connectors eliminate the need for adhesives and polishing for field termination. Instead, they use a factory terminated connector with a stub fiber and a mechanical splice to terminate the fiber. Termination only requires preparing the cable, cleaving the fiber, inserting it in the connector, and fixing it with a special tool. These connectors are very fast terminations, but not without their downsides. Since there is a mechanical splice and a connector, the total loss includes a connector loss plus a splice loss. Since the splice loss is dependent on the quality of the fiber cleave, it requires a very precise cleave from a top quality cleaver. Since the fiber is not attached with adhesives, the attachment strength depends on a good crimp. But the latest generation kits from most manufacturers solve these problems, so pre-polished splice connectors can provide a very fast termination. The economics of pre-polished splice connectors is based on the lower time needed for each termination. The manufacturing process makes each connector more expensive, and the good kits with quality cleavers are more expensive than adhesive polished termination kits, even those with epoxy curing ovens. However, the lower cost of labor can make these connectors cost-effective, especially when only a few connectors are being used at a given location. The secret to lowering costs is getting high yield of good connectors, and that depends on having the right tools and training and lots of practice. The other trick to pre-polished splice connectors is using a visual fault locator to determine that the splice is good. Bad splices leak lots of light and are visibly bad. At least one company, Corning, has developed a tool for pre-polished splice connectors, which they call Unicam connectors, that utilize a visual fault locator to verify that the connector is good. That's the connector we're going to demonstrate now. We're going to demonstrate terminating an optical fiber with a Corning Unicam connector using the new Pretium kit. First thing we're going to do is to take a connector, an SC in this case, remove the dust caps and insert it in the tool. Press the load button, put the connector in place, making sure it's fully seated, and then seat the VFL, turn the power on, we're ready to go. You take the fiber, put the boot on the fiber, and mark the fiber at two positions, at 40 millimeters and at a further 11 millimeters. Using the stripper, we strip the fiber first of the 900 micron buffer and then the 250 micron. Pull out a clean wipe, moisten the wipe, and clean the fiber by wiping it twice. Next, we cleave the fiber. Following the directions, we insert the fiber in the tool, rotate the knob one time, release and pull out our fiber scrap, put it in the slot in the cleaver, release the cleaved fiber. Taking our Unicam tool, we insert the fiber in the back of the connector. You can probably see the light from the VFL. When it's fully inserted, we put a little bit of pressure on it, cam it so you can see the green light, indicates it's a good connector. Crimp it by turning the knob on the base, open up, push the VFL back, unload. We can now reset it, turn it off if we're not doing more connectors. Move the strain relief boot back up and push it on the connector. Then insert the connector body. Snap it on, put the dust cap on, we're finished. The FOA thanks Corning for providing the Unicam kit used in making this video.